Hello guys, today I'll briefly explain to you what AC means or AC current, and it was first this AC current was first discovered by the scientist named Nikola Tesla, and AC stands for alternating current. So let's begin. For understanding AC, the first thing you need to understand is DC. So, what is DC? Sorry. DC means direct current. So, let's take, for example, this battery. This is a 9-volt battery and it has two terminals. This is a positive and this is a negative. So this is a positive and this is a negative. So if we take this as two lines, this line, so the wire, this is the wire connected to this line, this positive line, and this is a wire connected to the negative line. So this line will always contain the positive charge and this will always contain a negative charge. It won't reverse. So whereas in AC, so whereas in AC, if these are two terminals of an AC wire, and for an instant here might be positive and this might be negative, and in the next instant it could become here negative and this positive. So this is a brief explanation of AC, and it continues like this, then like this, and like this. It would continue like this. So if we draw a graph, an AC sign shall always be like this or like this, or it could be in any pattern, but it shall go to the more positive and negative part of the graph. That's the main important part of an AC. So here you can understand what means. I just briefly explained what AC is. So here I'll just explain it once more. So take two terminals of an AC, and for one instant this cable might be positive and the other might be negative, and for the next instant this might be negative and the other might be positive, and it continues like this. So I hope you can understand that this AC. And the next main thing of AC is frequency. Frequency means is a so you might have heard that the AC current which we get from our power line is at 50 hertz. So what does that mean? 50 hertz means that two terminals if we take, and as I told earlier, one might be positive and this might be negative. For the next instant this might be negative and this might be positive, and this cycle continues for 50 times in 1 second. So this one process and the other process takes place in milliseconds. So that's what frequency means. Now let's move on to the waveform. So you might have heard about sine wave or square wave or triangular wave, or there are many types of waves like this. That actually depends. So if we draw a graph like this, the AC current which we get from our power line is sine wave. Sine wave looks like this. Here. And this is an sine wave AC current and square wave. Square wave looks like this. And triangular wave looks like this. This I don't have. This is the triangular wave. So I am doing this video because I was planning to make the next video over the topic of an inverter. So I thought this would make it easier for you to understand. So let's repeat. I'll tell you once more. So what is AC? AC means an alternating current. Alternating current means if we take two terminals, for the first second here might be negative, positive, positive, negative, like this it continues, and the one cycle of this much is known as one oscillation. Whereas in DC, when we draw the graph, this DC, I hope you can, sorry, DC means all the time the graph will be a straight line. If this take for 5 volt example, so this will be a constant, just a straight line, it won't change when we draw a graph. Whereas in AC, the graph might be like this, negative 5 volt if we draw here. So this is a peak volt, you can see. It's a rough drawing. So this is the peak voltage. This is what is taken as 5 volt. So this becomes a 5 volt AC line, and here you can see it goes to the negative. And this AC can be measured using a normal multimeter like this. It's not a normal, it's a little bit expensive one. Here you can see, here you can see a V and a line like this. This shows an AC line. So this multimeter could read up from, it has two voltage not rating, it could measure till 600 volt AC volt. And for DC it's another simple. And for DC, here it's a DC, it's like this, you can see. So here it could measure till 600 volt AC or either DC also. So I hope you understood what AC and DC means. It's just simply an explanation for you to understand the general term, and what I told may not be 100% correct, but you might understand what AC and DC means. So one more thing I'll tell you, this is just an extra information So I'll tell you why AC is preferred in AC line, I means power line, and why AC is used in the power grid and other things. Because uh, AC voltage can be stepped up or stepped down using a transformer. This is a symbol of a transformer. So the transformers could easily increase the voltage of AC or decrease the voltage. I can't say voltage clearly because I could say voltage because it could I'll just explain to you simply. So let's take a transformer here. This is a step up transformer. Let's imagine like this. So this is a step up transformer. So here is the iron core, and so this is in and this out. So if we apply it's just an example. If we apply 5 volt here, we 5 volt AC, it could give us an output of let's take 20 volt AC, and here I am inputting 20 ampere of current, amps. This 20 amps of current I am inputting. So it would give it would give out an output ampere of 5 amp. We could calculate this using the formula P equal to VI. So power in a transformer, we can't increase the power. It will just, the power in the input and the output will be almost same, because there might be losses in the transformer due to eddy current and the resistance of the primary coil, the secondary coil, and so the power cannot be increased. And the main reason why we use AC in our power line is because AC could be stepped up like this or just reverse it. So if we change here and write, and this was a step up transformer, and if we write in here and out, then this becomes a step down transformer. I hope you could understand what I'm meaning. So it's much more easier to control AC, and the main reason is we might have studied the formula P equal to I square RT, or no need of power, just take work. So work equal to I square RT. So as power equal to work by time, P equal to I square R. So P equal to I square R, and let's so in the thermal power plant or in the nuclear power plant, where the means current is produced, so they would produce it at, for example, 220 volt, 220 volt, 220 volt. So if they 220 volt, and I can't measure the current because it might be in kilo amperes. So let's take, for it's just an example, it's not so much less, I'll take 10 amp. As P equal to I square R so here the P would be, and let's take this power line. So this is the post in which the current goes, and for 1 meter let's take a resistance of 1 ohm. Then the power lost in just transmitting this line is P equal to 10 raised to 2 into 1. So it would be 100 watt. So there's a huge loss of power. So we have to step up the voltage and decrease the ampere. Stepping up the voltage means, so normally we step up this voltage to 10 kilovolt. So 10 kilovolt, and this ampere might decrease to some point value. So the power loss in this line, transmission line, decreases. That's why we prefer AC, as AC could be stepped up or stepped down easily, whereas DC cannot be stepped up or stepped down. And one more thing, DC can be stepped up or stepped down, but it's a very difficult process, and it's commonly used, commonly called buck or boost converters. It's commonly called buck or boost converter, and it works in a principle of an inductor that I'll explain to you in another video. This could only step up or step down the DC current up to some maximum of 100 watt. But whereas in our home, just in one city, you might be using some thousands of kilowatt or megawatt. That's why we can't use this in a normal situation. And this boosting and bringing down of the voltage is much more inefficient, as this buck or boost converters might be just 60 to 75% efficiency, whereas a transformer with a good core and well insulated winding might give up to an 80% efficiency. Thank you guys for watching my video. If you understood something about AC or DC, just like my video, subscribe to my channel. If you couldn't understand anything, just ask to me the doubts, and in the comment section I will clear it as soon as possible for you. Thank you guys.